The turbo system, also known as a turbocharger, is a component used in automobile engines to increase power and efficiency. It utilizes the exhaust gases from the engine to compress the air entering the intake system, allowing for more fuel to be burned and a greater amount of energy to be produced. The turbo system is mainly composed of two elements, the turbine and the compressor. The turbine is connected to the exhaust manifold and uses the energy from the exhaust gases to spin a wheel that is connected to the compressor. As the exhaust gases pass through the turbine, the airflow towards the compressor is accelerated. The compressor, in turn, increases the air pressure entering the intake system. This allows for a greater amount of air to be introduced into the engine cylinders, which improves combustion and increases the power generated. One of the main advantages of the turbo system is its ability to increase engine power without the need for a larger displacement, resulting in lower fuel consumption. It also helps reduce emissions and improve throttle response by providing more torque at low revolutions. However, the turbo system also has some disadvantages. It can generate an increase in the temperature of the compressed air, which can lead to detonation issues if not properly controlled. Additionally, the turbo system can add complexity and additional maintenance costs to the vehicle. In summary, the turbo system is a technology used in automobile engines to increase power and efficiency. It harnesses the exhaust gases to compress the intake air, allowing for a greater amount of fuel and energy generation. Although it presents some disadvantages, the turbo system is widely used in the automotive industry due to its performance and efficiency benefits. There are several types of turbochargers for cars. Some of them are fixed geometry turbo. This is the most common type of turbo and its geometry is designed for a specific range of engine revolutions. Variable geometry turbo. This type of turbo allows for adjusting the geometry of the turbocharger blades to adapt to different ranges of engine revolutions. It provides quicker response and more consistent boost in a wider range of engine revolutions. Twin-scroll turbo. This turbo uses a divided housing into two compartments, allowing for separation of exhaust pulses from the cylinders and minimizing interference between them. It provides quick response and higher torque at low engine revolutions. Twin-entry turbo. This type of turbo uses two separate inlets for the exhaust gases, allowing for greater airflow to the engine and higher power. Internal wastegate. Some turbos feature an internal wastegate, which helps control boost pressure by releasing additional exhaust gases when necessary. Twin turbo. This configuration uses two turbochargers, one smaller and one larger, to provide quick boost at low revolutions and additional boost at high engine revolutions. These are just some examples of the types of turbos that exist for cars. It is important to consider that the choice of turbo will depend on the type of engine, performance goals, and driver's needs.